Okay, let's talk about creating a depreciation schedule in Excel. I'm going to start by creating a formula for each column, and then I'll show you how to combine them into a lambda function so that we can create the whole schedule with a single formula. Before we start, I just want to note that these green cells here, I have named them cost, salvage, start, and periods. You can see I've put a label here. But I've just done that so that the formulas that we write are easier to read. So let's start by creating a list of periods. We do that with the sequence function. And we want the list of periods to be 6, and we want another one for the year in which the asset was purchased. So it's periods plus 1. And we start at 0. 0 is the year at which the asset was purchased. And that gives us a list of integers from 0 to 6. Now we want some labels for these rows, and the labels are just the years that the depreciation applies to. So really that's going to be start, which is that value in B5, plus this array here, and we can just type the hash mark after the A11 range to get the array, and that will give us the list of years. So for depreciation, there are a number of different functions we can use, but I'm going to start with the SLN function, which calculates the straight line depreciation for a fixed asset. And we want that will give us the same value in every row, but we want a 0 in the first row. So to do that, we will use if this array is equal to 0, then put a 0. Otherwise, put the straight line depreciation and that gives us the depreciation of $15,000 per year. For the accumulated depreciation, there's a few ways that we can do it, but I'm going to use the scan function. And the scan function will step through each row in this array, and it will sequentially add the value from that row to a total. And on each row in the output, it will output the current value of that sum. So just to show you how to do that, I'm not going to go into minute detail about this, but we start with 0 and then we pass it this array, and then scan expects a lambda function with 2 parameters. I usually use A and B, where A is the accumulated value, so that's the result of the sum on each row, and B is the value in the array on the current row. So if I just put A plus B, you'll see that it adds the current row to the previous row's sum. So it increments by $15,000 to the total accumulated depreciation of $90,000. And then the depreciated asset value is just the cost minus the accumulation, such that it decreases by $15,000 down to the salvage value of $10,000. So you can see that that's the way to do it. You can use 5 columns like that, and if you do it that way, you can change this and it will update. And if you change the salvage, it will update. You'd want to format it better than that, but you get the point. So let's put it back to a manageable number. So that's all well and good, but I don't want to have to type out 5 formulas every time I want to do this. So I want to create a lambda function that will do this for me. So what I'm going to do is I'm going to take these 5 formulas, I'm going to combine them and parameterize them into a lambda function. So let's do that over here. And when I'm writing a lambda function, I usually start in the spreadsheet, and I don't use lambda to begin with. I start with let. So we're going to define some variables with let, and let will be let the periods be equal to the sequence that we used in the first column, which is periods plus 1, 0, So that's the periods. That's the first column. And the second column is the years. And I'm going to call this the period labels for reasons that will become clear later. And that is the start plus the periods. So the start plus the variable periods. Now I'm using these underscores. You don't have to use underscores for the let variables. I tend to, so that I can remember which is a let variable and which is a parameter. That will become clear in a moment as well. So that's the second column, period labels. And the third column is the depreciation, and I'm going to call that DEPR just for short. And for this function, the depreciation was, if you remember, if periods equals 0, then 0. Otherwise, it's SLN, cost, salvage, periods. So that's the depreciation column. And the accumulated depreciation was scan 0, and we're scanning the depreciation column, and we're using a lambda that adds A and B. So add the current row to the sum of the previous rows. And the depreciated asset value is the cost minus the accumulated column. Now, if we just very quickly use the output variable name, and we can use choose, and we've got 5 columns, we can put them in the order that we want. So actually I'm going to put the years first, which is the period labels, and then the periods, and then the depreciation, and then the accumulated depreciation, and then the depreciated asset value. So that will be the output for this let statement. And if we close the let statement, you can see that it's created this array. And actually you can see that these are now the same numbers as this. So that's pretty good. We've done that with a single formula. A couple of things that we need to do are add a header row. I'd like to add a header row. And then I'd like to be able to parameterize the calculation that's used for the depreciation, because we've used the SLN function, but there are others. So now that we've got this as a kind of basis of a lambda, I'm going to copy this formula and open the advanced formula environment, which is on the home tab. And I'm going to create a namespace called DEPN for depreciation, because I'm going to create a few functions here. Now the first one I'm going to do is create this function called schedule. And I start by typing the name equals and then the lambda. And remember, I copied that let function in here. So let's put all of that back. I just try to tidy things up and have each variable on a different row. Okay, so this lambda has a number of parameters, and the parameters are basically anywhere where we've got a name that is currently in the spreadsheet. So we're going to start with the cost, that's one parameter. The next one is the salvage, then we've got the periods, and do we have any others? The start year. So these, if I double click that, you can see it's used there. Periods is used several places. Salvage is passed into the SLN function, and so is cost. So this now has created a lambda function called DEPN.schedule, and we just pass these 4 parameters into it, and it will produce the same table that we've got. So now that that's created, we can click this sync names with the Excel name manager. And now if we close that and go into press Ctrl F3, you can see that depn.schedule is a function in the name manager. So as well as being able to do it with the let function, we've now simplified to do it this way. Cost, salvage, periods, and start. Remember, these point to the names in the spreadsheet, and it produces the same thing. So instead of 5 columns, 5 formulas, instead of one long let formula, we have a simple function call with a name, depn.schedule. So let's get rid of this let formula, we don't need that anymore. And we'll bring this one up here. Now what we want to do is change this, change the definition of this lambda so that it gives us this header row as well. So let's go back to the advanced formula environment. Okay, so here we want to define a header row. So let's add a variable called header, and it's just going to be an array of values. Now I've put the years first and period labels, so period labels, and then periods, and then, and you get the point. So that's the header. If I wanted to have the function just return the header, I could put that as the last statement in the let. And if I press sync, you'll see that it's just returned the header. But actually what I want to do is have it put the header on top of the output. So in order to do that, I'm going to rename this output variable to array. And I'm going to create a new output variable, which I'm going to use the makeArray function to create a new array that will have the header in the first row, and then in every other row will be the data from the original array. So makeArray, you define 3 parameters. First, the rows, which will tell it how many rows in the new array, and then the columns, and then a function to populate the new array. So the number of rows is going to be the number of periods, which in this example is 6, plus 1 for the period 0, which is the year the asset was purchased, plus 1 for the header. So it's going to be periods plus 2. And the number of columns is 5, because there are 5 columns in the array. And the lambda has 2 parameters, one for the row and one for the column. And I usually use R and C for this purpose. So what we want to do is we want to say if the row is 1, then we want to get the value from the header. The header has 1 row, and we want to get the value from column C of the header. If the row is not row 1, then we want to get the value from the array. And that we want to get that from row R minus 1, because on row 2 of this new output, we want to put the data from row 1 of the array. Okay, so that's R minus 1 and column C. I'm missing something here. There's a comma that goes there. Okay, so we are creating an array with periods plus 2 row, 5 columns, and we're populating it with this function. If the row is 1, then take the value from the same column in the header. Otherwise, take the value from R minus 1 row and column C of the array variable. And if we again put the output variable as the last statement in the let function and press sync, you will see that the EPN schedule now outputs correctly. We've got 7 rows, 5 columns, and a header. So that's great. So this function currently outputs the periods on the rows. Now I know that many financial modelers prefer periods to be on columns and the different variables to be on the rows. So we can add some detail to this function by changing the orientation using a parameter. So we'll add an optional parameter called vertical, and when we want it to be optional, we put these square brackets around it, and we need to add a variable to handle the cases where no value is provided. So i.e. we need to provide a default for that vertical parameter. So I'm going to call this variable v, and when we have an optional parameter, we use is omitted. So we say is omitted. If is omitted vertical, then we provide a default value. So we're going to say if it is omitted, then the default will be false. So it will be horizontal by default. Otherwise, we will put the value that is passed into the vertical parameter into this v variable. Further to that, at the bottom, we can now use that to either transpose the output array or not. So let's actually change the name of this to array with header, and let's call the output the output will be if v, then array with header. So if v is equal to true, then output the array with the header, exactly as we've seen before. Otherwise, transpose the array with the header, which will make it horizontal. So if v is false, we will have a horizontal array, and if it's true, we'll have a vertical array. And we can see that by pressing sync, the default is horizontal. So this is now horizontal because we didn't provide a vertical parameter here. So we can actually put a comma here. If we want to make it vertical again, we can make that true. And if we type false, it will be horizontal. And if we leave it out of the function entirely, it will use the default value, which is horizontal. But I like working with vertical arrays, so for now I'm going to leave it like that. So the next thing to do is to consider this header. Now it may be that we want to later feed this data into another function, and if we were to do that, we would not be interested in having the header there because it would just get in the way. So to handle that, we are going to add another optional parameter. This time it's going to be called return header. And because it's an optional parameter, we again need to consider whether it's omitted or not. So I'm going to define a variable called RH, and it's the same pattern as before, if is omitted, but this time we are putting the return header variable in that function, and if it is omitted, we want the default to be true. So if you don't pass a value to that parameter, it will come back with a header. Otherwise, we will use whatever the user has provided to that parameter. So if the user provides false, it will not have a header. So we've now got that RH variable. The next thing we need to do is use it. So I'm going to start by moving this calculation of output down one row, and what we're going to do is decide whether the header is there or not first, and then transpose the result of that. So we're going to say if we're going to return the header, then the data we want to return is array with header. Otherwise, it's just array. And then the calculation for the output is the transpose. So if it's vertical, then it's just the output. Otherwise, it's the transpose of the output. And the result of that, if I hit this, is now I can pass a false into return header and get the array back without a header. So why would I do this? Well, later I might just want to use this column or this column and put it into as a parameter into another function. And so now that I've got that as an option, I can use let d equal the return value from that function call, and then I can say index d for all rows for column 4. And that will give me just the accumulated depreciation. Or if I want just the depreciated asset value, I can get all rows for column 5. So that's the purpose of being able to remove the header. So now we've given some consideration to these optional parameters, and we need to take a look at this depreciation definition. So this is the definition of depreciation using the straight line function, but there are other functions that will calculate depreciation. So for example, if we just comment this one and redefine depreciation as if error and use the db function, which also uses cost salvage periods, and then we pass in the list of periods, the last statement, and a default. So that's how you calculate an array of depreciation using the db function. Now, of course, this is a different function call and different structure to this one up here. What we'd like to be able to do, or what I'd like to be able to do, is allow the user of depn.schedule to pass a parameter that tells it which depreciation function to use. So if I just show you that that does work, and I've changed it to the db function instead. Let's put this back. So this is now using a different depreciation calculation, but the calculation of the period labels, the periods, the accumulation, and the depreciated asset value is the same. The only thing that changes is this calculation here. So if it's just one thing that's changing, then that is a candidate for parameterizing that calculation. So to parameterize a calculation, what we can do is add a parameter where the parameter is a function. So I'm going to say, let's call it depreciation function is going to be the fourth parameter. And the definition of depreciation in here is just going to be if error, depreciation function, cost salvage periods and periods, and the default, if it's an error, will be a 0. So that will be how we will define this kind of anonymous function. And that's what lambda is. It's an anonymous function. So in the definition of depn.schedule, we actually don't know what depn fn is, because the user is going to pass a lambda function as a parameter to the schedule function. So what we need to do is provide the user with options, some lambda functions which allows them to choose one of these methods, sln, db. We'll create one for ddb and one for syd as well. So to do that, we can move this schedule one down, and you'll see that I'm just going to copy these from another workbook and paste in there. So just to quickly go through these, I've created 4 lambda functions here. depn.sln depn.db, depn.ddb, and depn.syd. So there are 4 Lambda functions here, and the reason we create them as Lambda functions is so that we can pass them as a parameter into another Lambda function. Now they're actually not that different to each other. You can see that the parameters for these native functions, these 3, they're the same. The only one that's slightly different is SLN, because the depreciation in each period is equal. So this function is just saying if the row in the periods array is equal to 0, then return 0, otherwise return the calculation from that SLN function. So now that we've got these 4 functions here, we can use their names as a parameter for this DEPN function, or rather as an argument for the DEPN function. So just to show you what it is that I'm talking about, if I refresh this, let's try again. DEPN.schedule. We're going to put the cost in, the salvage, the number of periods, the start year, and the function is going to be one of those functions. So DEPN, let's try DDB. That's the function. And I want it to be true, vertical. So the next thing I want to talk about is a response to a question that I had from somebody about whether we can create this schedule monthly instead of annually. The answer is, of course, yes. It's actually that the schedule is really only based on these period integers, and how we interpret what those integers are is entirely up to us. We can either say that they are a year between each integer, or a month, or really anything between each integer. So I'm going to show you how to change it, or rather parameterize this schedule function to have months instead of years. So to do that, we need to consider that this period labels column that contains the years currently is really just a calculation. And the calculation is start, which in this example is the year 2022, which is here, plus this variable periods, which is calculated from this sequence. So that in itself, adding those things together, is a function. So if we can consider that that is a function of 2 parameters, start and periods, then we can create that as a lambda function. Furthermore, we can create other lambda functions which take 2 parameters, start and an array of period integers, that calculate the labels in different ways. So the goal here will be to create, to first anonymize this calculation, and then create some lambda functions that we can pass as parameters to the schedule. So the first thing, let's just comment these out and define the period labels in a different way. So first, let's just say that we want an anonymous function called PFN, and which will stand for period function. And that anonymous function will take 2 parameters, and in each case it will be fed the start, which will be a year, or it might be a month, and it will take the periods variable, which is of course a list of integers, as we can see in column 2 of the output. So let's look at that again. This is the periods variable. So this is an anonymous lambda function called PFN. Now it's not going to start as PFN, it's going to start as an optional parameter called period function. Very much in the same way that we defined depreciation function, we're going to define period function, but this time it's optional. And of course, because it's optional, we need to use if is omitted. So if is omitted period function, then we are going to use some function which we have yet to define. Otherwise, we are going to use period function as the value to pass into the PFN variable, which is itself a lambda function, which we are going to call here. And it's essentially, PFN is just a name for some calculation that we are going to use to produce the period labels array. Currently, it's a very simple calculation of start plus periods, but that calculation really could be anything. And that's what anonymous functions are all about. So what we need to do is define what we can pass into this period function parameter. And as before, I do have some examples in my other screen, which I'm going to copy and paste over here just to save time. So I've defined two lambda functions here. One is called by year, and you would call it depn dot by year. And it's the same calculation that we saw before, which is start plus periods. I've just noticed I've got the parameters here the other way around, so I actually need to put periods and then start. Just need to be careful about that. So this lambda function, depn.byYear, takes two parameters, a list of periods, which is this, and a start. Now the start could, in the case of by year, it should be an integer, and the calculation is just start plus periods, and that's 1 year after another. So that's the current implementation, and if we pass depn.byYear into this lambda function in the period function parameter, it will use it as this pfn lambda function, and it will do the calculation start plus periods, which is what we had before. So actually I'm going to use that as the default. So if you don't pass a period function, the default will be depn.byYear. So you can see that the definition of this pfn variable is saying, okay, has the user provided a period function? If not, i.e. if it's omitted, then the default calculation for the period labels will be by year. Otherwise, we'll use whatever lambda function, whatever name, whatever calculation the user passed into this period function parameter. So that's how we define PFN. This is how we use PFN. And the available values for this period function are going to be either depn.byYear or depn.byMonth. After all that talking, let's just see how it works. I'm going to press sync. I'm going to get rid of that and get rid of this, and we're going to work on this side of the spreadsheet just to see how it works. So let's do depn.schedule. The cost, the salvage, the periods, which is 6, and the start. And the depn function is going to be depn.db. I want it to be vertical. And for a period function, I want to use depn.byYear, which is actually the default. And that just produces what we've been seeing all along. But if we change this to depn by month, this doesn't look very good. But that's because we've got 2022 in here and it's expecting a date. So if we put 2022-01-01, so January of this year, you can see the familiar date formatted numbers, and let's just change those to dates. Now I'm in the US, so the month is first, but you can see that it's now a list of months as the periods. And if I remove that parameter, it is now changed back to a list. It's now actually, because we've got a date in the start, this is now showing as a list of days, because it is still just adding these periods to this start. So if I want that to be different, I need to type 2022 in here, which is the start year, and just change that back to general. and reformat these as general. I'm sure there's a faster way to do this. So we can now switch. We just need to be a bit careful about the cell formatting when we switch between them. But you've now seen that we can define function parameters. So in this case, depn.db is the calculation of the depreciation. That's a parameter. We can switch between any of these four functions easily when we're calling the function. Similarly, we have defined an optional parameter for the period, which we've given a default value as by year, but we can also pass by month. Now, if you wanted to calculate your own period spread, so that's bi-monthly, you might want to calculate a new one, and let's say, well, I don't know off the top of my head how you would do that. I'm sure it's easy enough. But the point is that you can calculate as many of these bizarre period functions as you want, in the same way that you can calculate as many different depreciation functions as you want, and then pass those as parameters into the schedule. So it's really as easy as that. The only thing you need to be conscious of is the cell formatting. So like I said, if I put a month in here as a date, it has of course shown us these like this. And the easy way to do that is just to change it. So that's really it. You can define these lambdas in the same namespace. This is a namespace. And you can use them as parameters to a more complicated function, which you build up step by step as you realize how you want it to work and how you want it to change. And that's the end of the video.